Welcome back, ladies and gentlemen. Today we're going to continue our work with conic sections. Today we're going to talk about hyperbolas. If you remember from the previous drawings that I've shown you, a hyperbola comes about by slicing the pair of cones that are stood tip to tip, as shown in this drawing. And if you cut that out, lay it flat, and put it on a coordinate plane, it actually does look like the hyperbola that we talked during the earlier part of the year when we talked about it in function form. We actually have graphed a function that has the same shape as what we're about to graph today. The only difference today is that we are going to be dealing with functions that are not expressed in function form. So I'd like to remind you of a couple properties of this graph that we talked about earlier in the year. Firstly, that it has these two asymptotes right down the middle. And that forces some behavior, like as we approach infinity here, the function approaches but never hits 0. As we approach an x value of 0, the behavior of this function is unbound upwards from the right and unbound downwards from the left. So it approaches negative infinity here and approaches positive infinity there. And the same thing is happening over here. So I want you to be aware that this graph gets closer and closer to these asymptotes. That's going to be important for when we draw our hyperbolas today. And basically what we're going to do today is we're going to take this graph and we're going to turn it sideways. So if we do that, it looks a little bit something like this. So here's our function form, and you notice this passes the vertical line test. So no more than one intersection at any point on a vertical line. And what we're going to do is we're going to turn it sideways, either clockwise or counterclockwise. So there's two different possibilities here. We could turn it clockwise and we'd end up with this, with a hyperbola extending in the left and right directions. We could also rotate it the other direction and get a hyperbola extending in the upwards and downwards direction. Just as a reminder, those asymptotes are not a part of the graph, so the only piece of the graph is the curved purple part. And as with circles and ellipses, there is a formula for each. And because there are two different cases, there are also two different versions of the formula. The formula should be pretty easy to remember because it's basically the same thing as an ellipse. So it's set equal to 1. We have an x term, we have a y term. The only difference is that sign right there. It's changed from a plus to a minus. And we still sort of kind of have a horizontal radius associated with the value of a, and we sort of kind of have a vertical radius distance associated with the variable b. Now the way we get two cases out of this, a left and right facing hyperbola versus an up and down facing hyperbola, is based on which term is negative. You'll see right here that right here the x term is positive and therefore it faces left and right. And in this one, the y term is positive, the x term is negative, and it faces up and down. As it was before, we kind of cared which one was bigger, A or B. In this section of conics, we really don't care which one is bigger. We just need to know that everything vertical is associated with this term, everything horizontal is associated with this term, or vice versa if we're talking about the other equation. But the main thing that you got to know, just from looking at it, is basically the same information. You have a center that's HK. You have a vertical radius that is B, a horizontal radius that is A, and it is the positive term that will tell you which direction the hyperbola is facing. Now this is a little bit more complicated shape than we're usually dealing with, so when we go to graph these, we're going to want to make sure that we have a good template to follow. This is that template. So these are all the things that you're going to be required to graph, and I'm going to show you how to get each one of these dimensions. But the long and short of it is that we have to produce these asymptotes that the function approaches. So when you go to draw your final hyperbola shape, which will be well on down the line, so we have to be patient here, what you're going to do is you're going to start from the vertex and you're going to kind of gradually get closer and closer to the asymptote. So this linear line is going to dictate how you draw these on your paper. So you're going to start at the vertex and get closer and closer to each asymptote in each direction. Now what that means is that we need these asymptotes really badly, and in order to get these asymptotes we need to plot them correctly at the correct angle in the correct location, and they go through these 2 points right here in this center box. Okay, and this is not super complicated. We're going to refer to it as the box, which is pretty self-explanatory. And basically what the deal is this distance right here is going to be your horizontal radius determined by A. This is your vertical radius. So if we were drawing an ellipse, it would be inside the box. But this time we're drawing a hyperbola, so it's actually outside the box. You'll notice that I used the equation where x term is positive, so we got this thing facing in each direction. And there's 2 focus points that are outside of this box and facing outwards towards the left and right as well. Now the way we get all these distances is very similar to the ellipses. So we have a vertical radius, a horizontal radius, and then we have a distance from center to get to this focus. And we're going to use the same letters A, B, and C. And this time it is the Pythagorean theorem that relates them all. So we have this distance A, our horizontal radius, as by this equation anyways, our vertical radius of B, and then a distance from center to get to a focus. And all those numbers are related by basically the Pythagorean theorem that helps you get that. Now, as we are in a distance learning format, I also have another concern, is that I'm not going to have you graph these by hand and then send me a photo of them. So instead, I just want to make sure that you have all this background information that would lead you to draw the correct hyperbola. So in addition to the focus, the vertices, and the center, I'm going to ask you to report the top two corners of the box. So what I want you to report on the Schoology assignments is I'm going to ask for that coordinate and that coordinate as a pair as well. That just tells me that you would be able to connect the center to that point, draw that asymptote correctly, and then hopefully draw your hyperbola correctly based on all that information. All right, so if this seems complicated at this point, that's a fair statement. It is a pretty complicated graph to do by hand, but it's actually very satisfying when you get one done. So without further ado, let's go on to our first example. Take a moment and either print the notes or copy this equation down and give yourself a plotting area of that scale as shown. Okay, before we can figure out any of this, this needs to be in standard form. And you'll notice that we have a 16 over here, not a 1. So what I'm going to do is I'm going to divide every term by 16 to create a 1 on the right-hand side. And remember, that's really all we care about. But you'll notice that creates a 1 over 16 fraction and a 4 over 16 fraction, which we can turn over to 1 over 4. You'll notice that the y term is positive and the x term is negative. So that means we got an up and down facing hyperbola. And from there, we can interpret from this equation most of this information right here. So we have a y-coordinate of 2 for our center, an x-coordinate of -3 for our center. We have a horizontal radius of 2, the square root of 4, and we have a vertical radius of 4, the square root of 16. So we can fill in that information, and as I said before, the y term is positive, so that means this thing is going to be facing up and down. So now we need to basically start plotting it. So it's actually pretty helpful just to think like you're drawing an ellipse. So plot the center, go out your vertical radius and your horizontal radius in each direction. So you can see I've gone up here 4 dots and left and right 2 dots to go along with our horizontal and vertical radius. And then we're going to draw that box. So instead of drawing an ellipse at this point, we're just going to draw a rectangular box around all 4 of those points, as each dot as a midpoint of the rectangle. And then we're going to grab a straight edge, and if you're doing with this paper, yes, actually, this is fairly important to grab a straight edge. And you're going to lay that straight edge right on that corner, through the center, through the other corner, and you're going to draw the lines that go through each corner. I also took the time to write down those coordinates of the box, just the top of them. That's all I'm going to ask you to record on Schoology. Once I have those asymptotes, then I have the question, is it facing upwards or is it facing left and right? So then I just go back here. This is positive term is first, the y term, so it's facing up and down. So I do my best and I'd start drawing at my vertex and I start creeping towards this asymptote, put an arrow on each side. So I can throw that hyperbola shape in there, and then all I have to do from there is name my vertices. So I chose the top and bottom vertices, and then I have to calculate the foci. So I'm going to take my vertical radius squared plus my horizontal radius squared, related by the Pythagorean theorem. Solve that. That means that I'll have a C value of 4.5. So I'm going to count out from center. 1, 2, 3, 4.5. So my focus will be right there, and I'm sure it will be right there as well. So, and then name those coordinates. And then finally, you can plot them, or you can plot them and then name them. I don't care which order that happens. There is a complete hyperbola done. All right, let's do one more for today, and you'll notice this one is scrambled. So take a moment, copy down the equation, and give yourself a plotting area, or work on the notes that are posted on our website. The only difference between this problem and the previous problem is there's a little bit more algebra to do. This is going to be a completing the square problem, and there are a couple tricks as we deal with that, particularly when we deal with that negative leading coefficient on the x squared. So let's proceed. If this were a completing the square question, what we'd want to do is group all the x's and y's together and get that 172 over to the right. So let's do that. I'm also going to insert kind of that fill in the blank to help me out, just to know that there's a third term that's missing there that I want to figure out. And then we're going to factor out the leading coefficients because we don't want these here. The only issue here is that on this one, the leading coefficient is negative, so it's going to change all the signs. Now, no matter what the center, the x coordinate for the center is, when you square it, it will be positive. So you don't have to worry about that sign, but we do need to change to this sign right here. So this is going to become negative when I factor out a -9 from all three terms. So I'm going to factor out a 16 and a -9. You'll notice that the sign changed from a positive to a negative. I divided by 9, so we got a -4. And now I can ask myself what number goes in this blank. Chop this number in half and square it, so that'll be 4. Chop that number in half and square it, and it'll be, again, +4 as predicted. So throw those numbers in there, and then you have to figure out how much you added to the left-hand side. So I had 16 times 4, that's 64. And then be careful here again, this is a -9 times +4, so that is a -36 added to that side. So we're going to add a +64 and a -36 to the right-hand side to balance out what we did on the left-hand side. And from there we can start factoring and consolidating. So I can add all these numbers together. I can factor this trinomial into x minus 2 squared. I can factor this one into y plus 2 squared, and we get something that looks like that. Now check this out. I need a 1 over on this side, so I need to divide by a -144. Well, guess what? That's going to change the sign of both terms. So that means that the x term is going to be positive and the y term is going to be negative. So the signs are going to swap again. And the only other thing we have to do is simplify a fraction. So 16 over 144 and 9 over 144. If we do that, all the signs swap. I actually changed, see how the x term is right here, now it's their leading term. So 9 over 144 was 1/16, and 16 over 144 was 1 over 9. So I recorded that information, and from there I should be able to interpret my basic information. Here's my center, 2, -2, and my horizontal radius would be the square root of that, would be 4, and my vertical radius would be the square root of that, which would be 3, so I can record that information. I also know that the x term is positive, so now this one is facing left and right. And then now I can start plotting stuff. So I'm going to plot my center. I'm going to plot the 4 points around it, extending 4 to the left and right and 3 up and down. At that point, if I were drawing an ellipse, I would just sketch in a curve, but I'm not. I'm drawing a hyperbola, so I'm going to draw a rectangle that includes all 4 of those boxes, just like so. At this point, I'd grab a straight edge and I would connect the corners of the box, or name the top of the box, and then connect the corners of the rectangle, just like so. And now it's my job to either draw a hyperbola top and bottom or left and right. Since this one had a positive x term, we're going to draw it left and right, just like so. So now I can name the vertices. I'm positive that this one and this one are my vertices. And then calculate foci. So we take our horizontal radius and our vertical radius, square each, add them together. That ends up being a perfect whole number this time. So at -3, -2, or a distance of 5 from center. That's the easiest way to think about it. So count out 5, land there, count out 5, land there, name those points, or you can add it to the x term, whichever you choose. There's our focus points, and there's our vertices. We got our top of the box labeled, and we got all our basic information as well. And that would be enough to gain full credit on an assignment. So, speaking of, here's your assignment. You got a brand new worksheet 9.2. I'm going to ask you to do, I believe, 5 problems and report your answers to number 2 and number 7 on Schoology. I'll see you next time.